about him being born in a gypsy camp in Lower Silesia in 1904, but he rejected that introduction, so we'll have to go with the real facts for a change here. Anyway, Don is from Spring, Texas, which is a suburb of Houston, and he escaped Houston to escape the crime, and the crime followed him anyway, which is what it seems to do in those parts. He's an engineer by background, worked as a petroleum geologist for many years. About 8 years ago, he got out of that field, and that gave him time to start working with physics and free energy and chemistry and things he really wanted to do. Sometimes he works with the local school systems down in Texas. He teaches physics and chemistry and other subjects for the kids there, and he's doing quite a job, and he's been investigating various aspects of free energy, which he's going to give you a big presentation about today. So please welcome Don Smith.
Okay, thank you very much. Can you hear me out there? I hope everything's turned on. Can you hear me now? Okay. You're not going to be disappointed today. Since we met last year, I realized that there were a lot of people that had trouble understanding things unless you could turn the wall switch on, and that was the extent of it. So this particular speech is built around that particular aspect of it, plus the fact that I'm going to give you a lot of backup information, which you would probably never in a lifetime find if you went looking for it yourself. You just have to kind of fall into some of this stuff with dumb luck, and it seems like every time I've gone around a corner, there was something waiting there, which was what I was looking for. Now, those of you that have seen the article in the present issue of the Tesla magazine will have a lot of the theory that's here, and I will sort of bounce through that, and the speech is not written, so we'll have to work off of that particular aspect of it. What I'll do is go through some photographs here, and if we can dim the lights down, let's see what we can do with them. Okay, they probably need to be a little dimmer. Okay, can you see that? Okay. Okay, I'm going to walk you through the different parts on this. This is actual commercial model, and it's 30 kVA, and it's not very large. It's a little bit heavy because of the copper in the transformer. But the transformer is driven by an inverter, which is here, which runs off of 12 volts and kicks it up to 112 volts, and that in turn comes through through a variable deal that's very similar to what you have on the light dimmer in your house, except that won't work in this case. It's a special dimmer that's made for a neon tube to work with neon tube transformers, and you can vary it from 1 volt to whatever you have, like 112 volts. So that means basically that the forward going part of it going into the, you have a couple of 200 amp diodes here, one on each side. There's one here and then there's one there. And in this particular case, the diodes are not critical. They're silicone, but they're good for several thousand volts and 200 amps.
I believe you're standing in front of the projector.
Is that what's wrong? Does that work better? Okay. It goes from these diodes, it becomes pulsating DC at this point, and one diode will give you a sawtooth pattern, The second one there kicks in when will kick in and cause the other one to kick out at a certain point. So you have a continuous pulsating DC on a straight line instead of a sawtooth type arrangement. That goes to these 30,000 volt capacitors that are there, and they're set up to take hundreds of amps, and they're lifetime capacitors. They're self-healing, and I'll show you in a little bit the reading on one end of them. This is the transformer, and it may be dark, but you can possibly see what's going on. Okay, the closest to you here is your inverter. In this case, it's about 240 watts. The inverter, it goes into a 15,000 volt neon tube transformer. The neon tube transformer on each end here is kicking out the same amount where those knobs are. There's one on each end. Each one goes to one of the diodes. Okay, and the earth ground on this is here. So this fulfills something which we are going to talk about after a little while. There are many ways to wind coils. You can wind them where you have voltage only, or where you have very little amperage, or where you have 100% amperage and very little voltage. And the way the coils are wound will determine what you get. It has nothing at all to do with the fact that what you're putting in is, say, strict voltage to begin with. It's going to come out after it goes through a certain type of coil system. And with this center ground thing here, you're guaranteed that you're going to get amperage. Okay, there'll be a break at 10:15. And you'll have to let me know when that time comes, because I won't be able to watch the clock from up here. Okay, there's a lot of these photographs, so we need let's see, we saw this one just now, or have we seen this one yet? What we're going to do is walk around this commercial We're going to walk around the commercial model and look at it from different angles. And you see the 200 amp diodes sticking through these cooling fans, and you see the takeoff from those two going up to the capacitor. So it's going to be a lot simpler than the one you're looking at on the floor here. Okay, here's the same thing from a slightly different view. And below here you see a radio frequency high voltage probe that goes into a meter that measures high voltage at high frequencies. And I'm going to there's about 20 of these sheets, and then we'll go to some other things.